So credit where credit's due, coming up with a functional naming system was a bit of a heavy lift. The system we have now has been around for over 2 centuries, and all in all, it's held up pretty well. But some of the understandable misconceptions about the nature of matter got baked into nomenclature back in those days, and it can be very confusing to the modern student to sort that out. So once again, with concert shirt donned, I'm going to tackle yet another double-featured term, the wonder twins of trouble, the Jan and Zana of nomenclature, hydro and hypo. Sorry, Gleep, or whatever that monkey was. Was it Gleep? I don't remember. Now, hypo is really not the troublesome twin of these two terms. Hypo is used in chemistry much the same way it's used in other aspects of science. It means less than. So hypo is used in chemical nomenclature specifically for polyatomics, groups of atoms that act as a single charged entity. And now I do have another video all about polyatomics where I go into this in more detail. But essentially, different polyatomics have different amounts of oxygen. And hypo is used when you're at the bottom rung of available oxygens. So for instance, a polyatomic might be chlor 8 with 3 oxygens. The lowest iteration of that is hypochlorite, and that only has 1 oxygen. So when you see hypo at the beginning of a polyatomic, it's telling you that's an extremely low number of oxygens. But don't think you're going to get away that easy today. Hypo might not be that bad, but hydro, well, it doesn't really make a whole lot of sense. Hydro is a prefix that is a red flag for acids, as in hydrochloric acid. And what hydro means is that that acid contains no oxygen. So trying to figure out why some acids get the prefix hydro when all acids essentially contain hydrogen was a little bit of a history mystery. I mean, I had to buy a book to figure this out. A book! You know it's a tough answer when you can't just look it up on Wikipedia. So like most of my good chemistry stories, this one too starts around a certain dashing 18th century guillotined chemist named Anton Lavoisier. In the 1770s, Lavoisier had convinced himself that the source of acidity was the presence of oxygen. Now, Lavoisier called the chemical oxygen to denote its connection to acidity. Oxys was the Greek word for sour, a property of acids, and genus means to form. So, sour former. The very name oxygen was a tribute to the importance of acidity. So although Lavoisier saw oxygen as a source of all acidity, it did not take long for other chemists to start challenging him on this. The French chemist Berthelot noticed that prussic acid didn't contain oxygen, now known as hydrocyanic acid. The famous English chemist Humphrey Davy noticed that muriatic acid, now known as hydrochloric acid, didn't appear to contain oxygen either. But remember, Lavoisier was the king. And if you're going to take a shot at the king, you better not miss. So here enters Joseph Louis Gay-Lussac, known for his eponymous gas laws, but honestly, he did a lot of other stuff. Now, there were problems to an oxygen-centric view of acids. Gay-Lussac could find lots of compounds that contain oxygen that weren't acidic. Take for instance, water. And conversely, he could find acids that showed no apparent source of oxygen at all. But so entrenched was Lavoisier's oxygen-centric view of acidity that Gay-Lussac was not angling for a revolution. In fact, he was just really looking for maybe a little bit of remediation. So in 1815, Gay-Lussac proposed that oxygen was indeed the principal acidifying substance, but it was not the only acidifying substance. And so Gay-Lussac maneuvered through this mental minefield by creating 2 categories of acids. The first category contained all the classic oxygen acids that Lavoisier had championed: sulfuric acid, nitric acid, carbonic acid, etc. But what Gay-Lussac did is he created a second category of acids. These were the acids that appeared to contain hydrogen and then some other substance. And as far as I can tell, Gay-Lussac was the first person to use the prefix hydra to denote these kinds of acids. Now, it's important to point out that Gay-Lussac did not think that hydrogen was the acidifying principle of these compounds. In fact, just the opposite. So entrenched was Lavoisier's ideas of acidity being linked to oxygen that Gay-Lussac assumed that it was the other elements that were like oxygen that was causing the acidification, the elements like the chlorine and the iodine and the sulfur, not the hydrogen. But it would take another 20 years for a German chemist named Justus von Liebig to put hydrogen in the driver's seat when it comes to acidity. But that is a story for another day. So to review, hypo is used at the beginning of polyatomics to denote less oxygen, specifically 2 less than the common stock model. And hydro is used exclusively in acids to indicate that it does not contain oxygen. Hopefully this video helped give you a tad more appreciation for the chemical giants on whose shoulders we now stand, or sit and watch YouTube videos. Now that I think about it, it's pretty cool that both hypo and hydro are really linked and related to oxygen. It's almost like they're siblings. Perhaps they really are the wonder twins of nomenclature. Keep those around you safe, check up on a friend, and have a great day.